So today we're going to be discussing what a reference angle is. It's a pretty interesting situation. So to begin with, to show you this without you knowing what it is yet, figure out what these are. So plug them into your calculator and do the sine of 60. Make sure you're in degree mode and figure that out from there. Okay, so how did this happen? How is the sine of 60 exactly the same as the sine of 120? Cosine of 45 and cosine of 315 are the same thing, and tan of 110. Okay, these are just random numbers, really, that I picked, but I chose the second one strategically, and this is how it works. These things are called reference angles. They're the same because they have the same reference angles. So these are things that you have to remember about them. So memorize them, do something. Reference angles associated with every angle. So every angle has a reference angle except the 90, 180, 270, 0, and 360. Those, and any multiple of 90 will not have a reference angle. So it has to be inside a quadrant. The reference angle is always acute, so it's always less than 90. Less than 90. And it's always formed by the given side of the terminal side, the ending side, and the x-axis. So it's not a standard angle where we use the positive x-axis as the starting point. It is just an angle that we can draw anywhere, but we always make it with the x-axis. They appear in all four quadrants, but interestingly enough, quadrant 1 are their own reference angles, and you'll see why in a sec. Okay, so if I'm in quadrant 1 here, the reference angle is formed by the terminal side and the x-axis. So it's that. So that's why it's its own angle, 60 degrees. So this angle is 120. Its reference angle is 60. And the reason that is because this is the angle in standard position. Okay, but its reference angle, so it's not its standard angle, its reference is formed by the terminal side and the x-axis. So this side and the x-axis create this angle, and that degree is 60 degrees. We've done a bunch of those like that, kind of doing the opposite, where I've given you this and you had to find that. So it's similar, just kind of the other. Okay, and if you're in quadrant 3, this is the terminal side, so it's going to be formed with the x-axis there. It's always formed with the x-axis, and in quadrant 4, the reference angle goes to there. So remember, it's always the terminal side and the x-axis form your reference angle. So it's a special angle, and we're just learning how to find them. Just be careful you watch out. It's not the y. So take a second here and see if you can figure out. Just draw, not what is it, but can you just label the reference angle? So the reference angle is formed by the terminal side and the x-axis. So this is the reference angle right here. Terminal side, x-axis, right there. Terminal side, x-axis. Terminal side, x-axis. So that's where the reference angle would be if we knew what the actual angle was to start with. Okay, so find the reference angle for the following angles. Okay, so if it's positive and it's acute, we're done. So remember, things that you have to know, it's always got to be positive and it always has to be acute. So this one is positive, it's less than 90, 50 is its own reference angle. Okay, 250, not acute. It's positive, but it's not acute. Not as acute as me. So what we want to do is we want to think about, okay, where is that angle? Where is 250? Well, it's right about here. If I want to make an angle, this whole thing is 250, correct? So if I want to create, where is the reference angle? It's between this angle and here. So the terminal side and the x-axis. What is that reference angle? Take a second and see if you can reason it out. Okay, you may want to think of this as, well, I want to basically cut out 180 degrees right here. This whole thing is 250, but all I want is this little piece right here. So let's cut out the 180. So we subtract the 180, and it's simply 70. That's the reference angle. So with this one, the next one, take a second and convert it and see if you can find the reference angles. Okay, so as you can see for this one, the angle was 510 if you converted it to degrees. I don't really care how many times it loops around. I'm not sketching it. So I'm going to subtract 360 and get 150. So the real angle is 150. Okay, but what I want is what the angle is when it forms with the x-axis. So what is that angle? So remember, you're just learning how to do this. We're going to be using it and understanding it, I guess, a little bit more later. So this is your reference angle right there. So think about it. This is, whole thing is 180 degrees. This whole thing is 180 degrees. I want to cut out this angle here, the 150. So it's 180 minus 150, or 30 degrees is the reference angle. Okay, so try it with the rest of these, and we'll come back and look and see how you did. Okay, so to quickly go over this, you have negative pi over 3. It converts to negative 60. Well, negative 60 is acute, but it's not positive. So technically, you just take the positive of it. It goes down to negative 60. There it is. So over here, this is negative 300. So this is this is negative 300 from here all the way around. So I like to think, how much more do we go till we get to 360? Negative 360. Well, I have 60 more to go, but it has to be positive, so it's positive. Another way to do this is you take negative 300, negative 300, and find something coterminal to it. So add 360 to it. So 360 is 60. Well, it's in quadrant 1, so that's why it can be itself. It can be just 60. And the last one here, we convert this and we get 500. That's what I got. Subtract 360, so I can find something, that I understand, the coterminal. And I get 140. So this is 140 here. The whole thing to the x-axis was 180, so I just do 180 minus 140, and I get 40, and that's our reference angle. Okay, so it's always, basically you have to get to the x-axis. You either have to get to 180 degrees or 360 degrees. If it's in the quadrant 1, it's just 0, but you don't have to worry because it is itself. So you either have to get it to 180 by subtracting here. 140 plus 40 is 180, or if you're in this quadrant down here, you subtract it from 180. Yeah, so this is where I kind of write all that out. This is all dealing with reference angles from angles that are positive. So if you have a negative angle like negative 75, well then you have to either make everything positive or know what you're doing going in the negative direction. Okay, so that's what we'll practice tomorrow. So what we want to do is kind of go back to what we did in that do now and say, what's the procedure for finding something equivalent values? So the first question we had was the sine of 60 is equal to the sine of 120. Those are exactly the same thing. So how do we do that? Well, this is how we do that. Just keep that in mind. Keep this out while we go through it. I will refer to it. So what we like to do is what's called the box, line, box method. To begin, we're going to be putting two things in each of these spots. On the line is just simply that same cosine. So cosine goes right there in the middle. And what we're going to do is in this box, we're going to put positive or negative depending on our ASTC. So 280 is in what quadrant? So let's kind of sketch it out. So 280 is greater than 270. So 280 is in quadrant 4. So quadrant 4, cosine is positive, so I'm going to put a plus. That's where that comes from. Now the reference angle, well, that's what we have to do. We have to just figure out our reference angle from there, what we just learned. So 280 is here, so I want to get to 360. So the whole circle is 360, and I want to cut out all of that 280. So I simply take 360, subtract 280, and I assume I get 80. So that's an equivalent value. If you put cosine of 280 in your calculator and cosine of 80, they should be the exact same thing. Okay, for this one, cosine of 5 pi over 9, you should convert 5 pi over 9. It does turn out to be cosine of 100. These are the exact same angle, so it's not technically an equivalent value. So this one right here is positive or negative. So you look at the 100, graph the 100. It's right here. It's in quadrant 2. So in quadrant 2, sine is the only thing that's positive. Oh yeah, that happened. Sine is the only thing that's positive. So cosine has to be negative. Then we find the reference angle for 100. So let me just draw it a little clearer here. This is 100. The whole axis right here, this whole angle is 180. So I do 180. I want to cut this out of the 180. So it's 180 minus 100, or 80. Oh, look at that. How exciting. So this is negative cosine of 80. All right, it is asking the question in radians, so the answer probably should be in radians. So let's convert that 80 to radians in terms of pi. And using my math magic, it's 4 pi over 9. Okay, I can't erase that. So it would be negative cosine 4 pi over 9. If you were to check this out in your calculator and you were to put the radians in, you do have to change your mode back to radians. Try this guy, all on the own. Okay, this one, sine of negative 110. This is what it should be. If you got that, well done. So negative 110 is here somewhere. This is in quadrant 3, so sine is negative. It has nothing to do with the angle. Nothing to do with the fact that the angle is negative. It has to do with what quadrant you're in, what quadrant the angle terminates in. And then you have 110. Remember, this whole thing is 180, regardless of whether it's positive or negative. The whole thing is 180. So I do 180 minus 110, and I get, you know, if you do it the negative way, you might get negative 70, but it's always got to be positive. Try this. Okay, this particular one, you should have got negative tangent of pi over 3, or negative tangent of 60. So when you convert 11 pi over 3, you get 660. Subtract 300, 360, just so you can get it in between 0 and 360, and you get 300. So 300 is in quadrant 4. So cosine is the only thing that's positive, so that's why the tangent is negative. And then the reference angle for that is 60, because the whole circle is 360. So we want to cut out the 300 of it. So it's 360 minus 300, which is 60, and then converted to radians is pi over 3. And finally this one. So this one right here should be negative sine of 45. It's in quadrant 3, ASTC. Tangent's the only thing positive, so sine is negative. And the reference angle for 225, you're cutting out this whole thing is 180. You're cutting out 180 of it, so 225 minus 180 is 45. Have a good day.